In this tutorial, we are going to learn about two different kinds of collision detection. The first kind uses the p5 function dist to detect the collision for circular shapes, and the second kind uses if statement, very similar to the hover button tutorial we've done, except this time to check collision for rectangular shapes. So here we are going to take a look at how dist function work. So if you see the screen, and you can see that my mouse X and mouse Y is constantly affecting the number that's being displayed along the line. So what that number is, it's a representation of how many pixels there are between the first ellipse and the second ellipse. So what this does is that it creates a direct line between two shapes, specifically between the anchor point of two shapes, and it will give you a reading on what the distance between the two shapes are. So this is incredibly helpful in so many ways in creating games, creating interactive pieces. Oftentimes you need a way to be able to find out the proximity between two different things. And you can create all kinds of events based on how close two things are. So if we look at the syntax for a second here, a dist function takes in 4 different parameters. So the first set of parameters is x1 and y1, and these are the position of the first shape, and x2, y2 for the position of the second shape. So let's actually get into a p5 editor and try it out ourselves. So I am going to create 2 different ellipses and find ways to figure out the distance between them. And so the first ellipse is going to be placed at the center, and it's going to be static. It's going to be at 200, 200, and 50, 50 for width and height. The second ellipse is going to be mouse X, mouse Y, 50, 50. So it's going to move around with my mouse. So if I hit play, that's pretty much what I have. And what I can do next is to create a let d, a local variable that is going to load my distance function every frame. So I'm going to say let d equals to dist. And I'm here then going to say the first set of x and y for my ellipse, 200, 200. The second set, mouse X, mouse Y. So from here on, I can maybe just display my text. So I'm going to say text and display the variable d, and I'm going to say 50, 50. And I'm going to hit play. So what I get now is the reading of the distance between my 2 ellipses, right? So you can see that when I get closer, the number decreases. And when I get further away, no matter in what direction, it is going to take that direct line between the 2 shapes as the reading for the distance. So this is an extremely useful function. And we can also apply, a int, which stands for integer, around my dist, so that I can get rid of the decimal number, if that helps you. So we can here now easily imagine a scenario. Maybe these are 2 characters, and one character walk up and can say hi, or the other character will say hi to the main character. So there's all kinds of triggers that you can implement as a secondary event that can happen based on this interaction. So this is how you would create a circular shape detection. We're going to jump into creating rectangular detection. So here I'm going to create a new sketch, and I'm going to follow a similar logic, creating a rectangle at 200, 200, and 50, 35. I'm gonna make the rectangle, not proportionate to make it just a little more challenging. And I'm going to create a second rectangle, 200, 200. And I'm gonna say this time maybe like 50, 50. Oh, actually I want my second rectangle to be mouse X, mouse Y. Okay, so I'm gonna hit play. So the idea is I need to be able to find out when my rectangle is transgressing the boundaries, of every side of this static rectangle. So the way we would do that is using an if statement. So what I'm going to say here is if. So we can even try to rehearse this, right? So if mouse X, which is like my avatar rectangle, if mouse X upper left hand corner of that rectangle plus 50, which is the width of my rectangle, if that point on the right of my rectangle crosses 200 on the X, then it's going to bump into it, right? So here we can say mouse X plus 50 larger than 200. And if we hit play here, then finish this if statement. And I'm going to say console log bumped. So hit play here, and we're going to see a lot of bumping. Right? So every time it crosses that line, it's going to do that. And obviously, we might have guessed that we need more Boolean expression to fine grain that like that rectangular shape there. So I'm actually gonna make my avatar rectangle smaller, just so that it's a little more proportionate. And then I'm going to add additional Boolean expression. So the second expression, what is it going to be? So my mouse X, once it hits over, mouse X plus width of the rectangle, once it goes over the static one, it's going to bump into it. Also, I want to refine it so that, the mouse Y of my rectangle needs to fit within the boundary of like the static one. So I'm going to say mouse Y plus 35, which is the width of my, the height of my avatar rectangle is larger than 200, right? So now my mouse Y, if it goes over here, it's going to bump. And now it's not. And if it goes over here, it's gonna bump. Okay, great. And now it's kind of confused again. So now we have to set up the two other Boolean expression here, and that's going to be mouse Y smaller than 200. If mouse Y is smaller than 200 plus 35. Right? So if my mouse Y is smaller than 200 plus 35, which is like the height of my static rectangle, is going to bump again. We can also put an else here just to make it more legible. So I'm going to say safe. So now everything's going to be safe. When I cross, it's going to bump. Safe. Cross, bump. And the top, safe. And when I cross, it bumps again. And the last side, which is on the right hand side, has not been considered. So here I'm going to add another set of Boolean expression saying mouse X smaller than 200 plus 50. So if mouse X, the upper left hand side of my avatar, is smaller than 200, which is the upper left-hand side of the static rectangle plus the width of that rectangle, right? So all these conditions have to satisfy for the bump to happen, right? So we're just defining that perfect boundary around the rectangle. So isolating these kinds of coding like outside of your like larger program is really helpful because you're not as concerned about breaking something, and also you can really take time to figure it out using simpler shapes, simpler mechanism, and have a logic established, right? And knowing that this works. It's just a matter of like turning this, converting this into like the larger program. So we're actually gonna use this little model that we have as an aid for continuing to work on the Frogger game. So I'm gonna take this out as a separate window here so I can look at it, and I'm going to check out our where we left off. So what we had last time with the Frogger tutorial is that we implemented a switch statement so that it now is able to switch scene when the frog reaches home at the very top. It's going to advance and level up, right? So I am going to actually comment out my switch statement just for a second because I don't want to keep seeing like scene 1 and scene 2 console.log. So I'm going to take that off. And the second thing that's a little bothering me with the current program is that currently when we generate the position for the car, we let it be anywhere, you know, inside the random width and random height range. Sometimes the car is positioned like lower than my frog, and I don't want that. So what I would do is going back to my random range, and I'm gonna say minus 100. So it's only always going to generate the car at 300 or lower, right? So that's much better. And what we're gonna do next is finding a way to add the ability to check collision into every single car. So each one of these car objects need to have their own individual way of checking collision. And the reason for that is because each one of them have their own independent X and Y position that's constantly changing, right? So they cannot share the same check collision, block of code. They all need to have their own. So that is what class and objects are very good at. All we gotta do is add a new check collision feature into our car class, hopefully. And so let's get into class car. There are a couple housekeeping that we should deal with for a second before we proceed. In the last example, checking rectangles, we heavily rely on, being able to reference the width and the height of the car as well as the frog. So let's actually turn these into variables. So that it's easier to reference them. So I'm gonna here say that I'm under class car, and I'm going to add this.w equals to 50, this.height equals to 35, and change my rectangle to this.width and this.height. And I'm gonna do the same thing for the frog. So I'm gonna add here this.w equals to 30, this.height equals to 30. Oops. Okay, this.w, this.height. And honestly, nothing should change. Everything should remain the same because all we did was to replacing numbers that were hard coded into variables. Okay, So let's go on to the more exciting part of this tutorial, which is adding check collision method, a new method into our car blueprint. So I'm gonna go into my car class and I'm going to say check collision, and I am going to actually do it. So I'm going to replicate that if statement that we have written for rectangular detection and port it in, but within the context of this program. So I'm going to say if the x position of our frog, right? So how do we do that? It turns out that we can write something called frog1.x. And this is like a really important moment, because now our car object, every one of them, can communicate with another object in another class. And this is really cool. And this is also why we had to write this.x, right? Because it has to, it just distinguish, whether the x variable belong to the local car object or belong to maybe some other, object, whether it's frog or other cars, right? So this is basically the syntax that you would use using a dot notation to access variables under other objects. So here I'm going to say if frog1.x is going to be added by frog1.width. So this is where it kind of differs when we're like working with a circular shape, right? Because the anchor point is not on the upper left, it's in the center. So we're gonna divide it by 2. So we're gonna start with frog1.x right in the center, and add the half of the width of that circle to this equation. So if that point on the right hand side of that circle is larger than this.x, which is the this very x of the car object, right? If that happens, then I'm gonna say console.log is going to say bumped, else console.log is going to say safe. Okay, so I know the Boolean expression is not done yet, but let's first test it out before we go too far. So we have to make sure we remember we load our method. That's always very important to remember. So let's go back to our draw function, and I'm going to say cars I.check collision. Okay, so here gonna hit play. So what I got just now is that it's a lot of activities going on. So it's mostly safe. Actually, this is it's like too hard to tell. It's too inaccurate. So let's actually there are too many cars that's interfering. So let's actually change the number of the car and decrease it to 1 so that it's not so confusing. Okay. So now we see that when a car was passing the frog by on the x-axis, it was Okay, so we only got one side of it covered, right? When it passes on the other side, it's safe. When it's on the left-hand side, it's bumped. Okay, so we got more work to do here. So let's come back down here, and we're going to say and frog1.x is smaller than this.x plus frog1 dot width divided by 2. Okay, so let's try this again. So if we hit play now, we're going to see that, okay, it's mostly safe and it's bumped and it's safe again, right? So it only would detect like that it's being bumped when the two shape aligns. Okay, so that's cool. Let's add additional booleans so that it would define the y-axis as well. Okay, we're gonna try again and move from the top. It's safe, 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 and bumped, and safe again. Okay, so now our collision detection works. Let's now bring up the number of the cars. So let's say we have 10 cars, and we want to make sure that each and every one of them is going to work, right? So now I have a ton of cars. If I run into any one of them, it's going to like create bumps. And it's actually really hard to see right now because we also have that safe being printed and it's distracting. So I'm actually going to take out my else statement. We no longer need that. And what I'm going to do is to make it so that whenever the frog collides into any of the boxes, it's going to be sent to the bottom of the screen. So what I will have to do for that is I need to somehow access the y position or the y variable of frog1 and assign it to a new position, resetting it, right? So here I'm going to write frog1 dot y equals to height divided by 50. So what this does is reset frog position. So let's try this. Exciting. So I'm going to come up here and get bumped, and it's gonna bring me back, and I'm gonna try again. I'm gonna get bumped again, and it's gonna bring me back, right? So this is the logic of adding check collision into our car class. It creates a feature that is shared by every single one of the car object, and yet they all operate on their own terms, right? So here, of course, now you have the overarching layout created. You can go in and fine tune a lot of details and add, kind of like sub additional features. So for instance, if I follow the logic of the Frogger game, we start with either 3, 5, or 7 lives, right? I'm gonna be generous to myself. I'm gonna say I'm gonna have 7 lives. So I created a variable called frog lives that has 7 lives. And now I can, I can do a number of things. I can do whatever I need to do. But maybe one thing I could do is I can create a frog live function, right? I'll do a function current frog lives, and I'm going to say, I can maybe make a for loop to display the amount of lives there are. So I can say for let I equals to 0, I smaller than frog lives, I plus plus. Right? Then I can here say ellipse and say that I'm going to have x position with the I, maybe I times 20, and y is going to be height minus 10, and I'm just going to say width and height is going to be 20, 20. And I can then load my function in my draw. So let's see how that looks like. Okay, so I have 7 lives currently, and of course then I can go into my check collision portion and add a additional thing that would happen when bump happens, right? So I can say right after the frog1 dot y position get reset back to the bottom, I am going to say frog lives minus minus. So if I hit play here, I go up, and I get sent back down, and I also see my frog lives keep decreasing, right? And I mean, you can do all kinds of things here, and obviously there's going to be a time where my frog lives is going to be equal to 0 0, and you can write in an if statement that with a game over screen or play again, whatever works. But this is the basic logic of how you can create collision uh, inside the context of class and objects.